So today on Scares and Sparks, we're going to build a thunder and lightning machine just in time for Halloween. If you find the video useful, please hit the like and please hit the subscribe so I can carry on making more crazy contraptions. Let's get a sneak peek of what it looks like. Really bright. So for this year's haunt, I wanted thunder and lightning set off on a timer. I looked at all of the options available. They were either too expensive or were a bit too basic and didn't really have the features I wanted. So I thought I'd just start seeing what I could do to create my own. I designed a unit based around my prop controller board using an Arduino, a music player and some switches. It will drive both AC mains lights and also DC 12-volt lights, which are the types I often use around the yard. You can adjust the sensitivity and you can also adjust the timer and when it goes on and off. The thunder track is stored on a little memory card inside the unit. You can put as many different tunes or sounds as you want on there and it will just cycle through them as you go through. So before I started on this, I decided I'd have a look to see what's available out there. A lot of people talked about a single channel colour organ, but I don't seem to be able to find that. I found a 3-channel colour organ, which was quite scary looking really, with mains connectors hanging off it, and seemed expensive for what it was. I've also found a kit from Velleman. They make all sorts of kits, look very nicely made. That only does 3 DC outputs and I had to use a microphone, which again wasn't really what I was after. Those are the only 2 DIY ones I found. Then you come to the Morris Perfect Storm, which is what a lot of people use. Fairly limited with what you can do with it. Single channel input from, well, they talk about a CD player, but of course it can be anything else really. And after that you're really up to more expensive things like the Pico Storm or the Firefly, which, you know, both well out of my league for what I wanted to do. I thought the Pico Storm had very limited functionality for the cost. The Firefly seems to do a little bit more and has a little screen on it, but again, expensive for what they do. I'm sure they're very good, but they're just way out of my budget. Just for references, a copy of the comparison matrix that I put together to show you the differences between them. So this is the guts of my lightning machine. It's now just reset, so it's going to come on in about a minute's time. It's based around my prop controller board, an Arduino, music player with a memory card. It's got a thunder track on it, little power supply and 3 MOSFETs. The output from the memory from the music player goes to a little audio amp, which connects to a pair of speakers. And on the low voltage side, these MOSFETs will switch 12-volt LEDs. I've got 2 mini spotlights, and I've also got this strip light going up here, which takes about 24 watts when it's on. It has got 2 controls. This one adjusts the time delay between lightning bolts. This one adjusts the sensitivity, i.e. when they come on or off again. I'll show you those working when it starts. Here we go. It's good timing. So I've actually got all 3 of these slightly with different thresholds to give a bit of a variation of their luminosity. Now I can adjust the sensitivity. I put it up really high. Only a really loud thing will get a blip. If I put it really low, then they're on almost all the time. So find your sweet spot where you want it to come on and off. And I'm just adjusting this knob, you can't quite see it in the picture, to do so. I can adjust the time between them, anywhere between about 1 minute and about 40 minutes. Best thing, I mean, is to put this all in a box, and then I'll put some markings on the box telling me, you know, 10 minutes, 15 minutes, etc. Now the other trick up its sleeve, it can switch 12-volt lights like this. I'm just turning the volume down a little.
but it can also switch AC power at the same time. So I'm using this thing. This is called a solid state relay. You can see its little red light is twittering. That's telling it that it's actually being triggered. It's providing power via this wiring box, which is going to this lamp. So if I plug all of that AC side in to the wall, then when the thing triggers, I think the lamp might be off. It was off. Then you've also got low voltage DC lights. So the strip light, great thing, then you can use these long LED strips like this, and mains power as well. And this thing can switch, this little box here can switch 25 amps. So I mean, this is about a 13 watt bulb. So tiny amounts. So you can put quite a few of these around to make a lot of lighting. So all that really needs to be done now is to put it in a box. I've actually got a random plastic box that I found in a dollar store type thing. I'm going to put the prop controller in there, the relay, and then bring out, you know, the signals and the pots and things like that, so we can adjust them while they're in the box. So overall, the cost of this thing is dirt cheap to make. I'll do a rundown of the costs, but I should imagine the entire cost of the thing is less than 20 bucks. That's assuming, of course, you know, you've got to have speakers, you've got to have an amplifier, and you've got to have some lights as well. But then all of those would be true if you bought an off-the-shelf one as well. All this is really doing is replacing an off-the-shelf one. It does more stuff than the box that sells for around $90. It doesn't do quite as much stuff as the Firefly one, which sells for like $400. But whichever way you look at it, $20 for this functionality, you know, it's a pretty good deal. Okay, here's the completed Thunder and Lightning controller in its box. Just walk around the cable. So here's the power input, 3-pin power input, taken from an old appliance. Here's the audio output that goes to your amplifier. Excuse me. I've got a DC power input. So this is when you're running it on. You really need this one in to power the whole system, and it also runs 1, 2, 3 separate DC light circuits. I'm fond of these waterproof connectors for the DC lights. Then around the other side, we've got knobs for adjusting how frequent the thunder and lightning is, and also the sensitivity for your lightning to see how much lightning you want, and a little power LED. Double output socket mounted in the roof of the thing. I 3D printed a little cover for the socket just so that it can go over there and protect it, so there's nothing can be shorted out and no fingers can get hurt. See, the wiring side is reasonably neat. You can get to the SD card if you need to. The actual board is not even held in, it's just sitting there loose, so I can easily get the Arduino out to reprogram it as well if I need to. But overall, quite a neat little setup, I think. Once it's shut, just looks like that. I'm going to hook it up to some lights and some speakers to give it one last test.
Okay, so let's take a quick look at how I wired this thing up. It's based on my standard prop controller, and what I'm going to do is show you basically the pieces on this board on the schematic that you've then got to fit onto the board. So I'm simply going to do this by highlighting them. So we need the power supply board, we need the Arduino, we need the music player. We're also going to need a capacitor on the music player. We're going to need a V-in capacitor. We're going to need all 3 MOSFETs, all 3 headers for the MOSFETs. And in terms of connections to the module between the music player and the Arduino, you actually need R1, R11 and also R9 because we want to listen to the busy line. There is also an extra connection that has to be made, which I will detail later. We'll also need the DAC output header because we're going to connect that to our amplifier. So if we have a look now on the PCB, it's highlighted in the lovely pink color, basically where all your components are going to look like they're going to go. So you can see the Arduino, the music player, a couple of capacitors, the MOSFETs. Now, I don't have models of the pins of the connectors on my circuit board, so you can't see them, but you're going to have, 1, 2, 3 sets of MOSFETs used. You're going to have the DAC output one over here used as well. And then you also have to, of course, supply power into the board over here, a 12-volt input. And if I flip the board over, you'll see on the back, basically these 3 resistors here are going to have something fitted to. R1 needs to be a 1K resistor. R11 and R9 can actually be 0 ohms. They don't need any resistance. So you could just put a little wire straight across those two, which is how I did it. Flicking back. What I'll do now is I'll just quickly show you what that looks like on the actual circuit board and talk about the extra wire that's needed.
Okay, so on the back of the board you can see an extra wire. This is going from the DAC output, so the one that goes off to drive the speakers, back into an analog pin on the Arduino, and this allows us to monitor the audio level. You can also see a couple of red wires soldered in here straight onto the 3.3 volt, and the reason being those go to the 2 potentiometers on the front. While you could supply them with 5 volts, the 3.3 is actually quite a bit cleaner in terms of noise, which means you're going to get more stable readings on those potentiometers. So you see the connections to the pots, I'm using the ground and the signal on each connection going off to these potentiometers, and the power goes underneath the board, solders to the 3.3 volt net.
So just to give you a quick idea of cost for the thing, this is pricing largely from Amazon. Sometimes it's just not worth buying the stuff from AliExpress. You get some real bad problems with things like DFPlayers, for example. If we go for Amazon prices, you can see the cost of the basic electronics and the box, etc., is about $25. Now you've got to add a micro SD card, wire, solder, screws, that sort of bits and pieces, and obviously you're going to need some powered speakers, but then you're going to need those for every single one of these implementations. So you see, it's a pretty cheap solution. Yeah, you've got to build up a circuit board and test it, etc., but it's pretty satisfying to get the thing working for a fraction of what's available. So the little Arduino is not going to do a lot without any software inside it. We're going to have a very brief rundown of the software. It's certainly not written in a way that's difficult to follow. No fanciness, really simple. That's very deliberate. I'm going to go through each section briefly in turn. If you get stuck on stuff, rewatch it or go and find, another type of resource. I am going to do a basic Arduino programming video in the future. So the first thing we've got, these are for debug. So these allow me to turn off various debug sections of code that will be compiled or not. So they're mainly for displaying things when I'm trying to work stuff out. Once I've done it, I can turn them off, cleans the code up. Next thing, we're going to include a couple of libraries. This is to support the DFPlayer Mini, which is the thing that makes the audio. Then we're going to actually declare an object which is effectively a software serial port to talk to the DFPlayer, and then we're going to put down an object which is the actual DFPlayer itself, which is very originally called my DFPlayer. A couple of variables, one to store the sound file pointer, one to tell it how many files there are on the SD card. It's not clever enough to work that out. Yes, you could write code to work it out, but it's really not worth the effort for this. Next thing I'm going to do is define all the pins used. So if you look on the schematic, you will see that these match up to the numberings on the actual Arduino. So 4, for example, is the one it calls D4 or data bit 4, and that goes to my MOSFET Q3, which goes to an LED, one of the LED DC outputs. And I've got 3 of those for the 3 different MOSFETs. I've also got a busy pin. This is the one we had to hand wire. Oh no, it's not, apologies. This is the one from the DFPlayer that tells me whether it's busy playing or not. And then actually you've got a little variable there that gets stored. I can move him away. He's not an input or an output. And then I have got the actual sensor pin that we wire in. This is the one we put the hand wire in. So this goes to the output, the DFPlayer, and allows us to effectively listen to the level coming out of the player. We've then got the two potentiometers. One adjusts its sensitivity, i.e. when it thinks it needs to fire or not, and one is the delay. We've got some variables to hold the trigger thresholds. So all I'm doing here is declaring one of them, and then the other thresholds are based upon that one with offsets on them. Another couple of variables to store older versions, and then some more values here for our timer. So we're actually using the clock inside the Arduino to count the minutes for the delay. So you can basically get it to trigger your thunder and lightning anywhere between about 1 minute and 60 minutes each time. And in use, I think mine's going to be around the 15-minute mark. So it's got the built-in clock. You don't need any other clock. Is it super accurate? You know, probably not. It probably drifts more than a few seconds a day. But for a Halloween thing that's only on for a couple of hours, that doesn't really matter. Now, we only got a couple of functions here. One is print time, simply writing to the serial port, showing us this time as it moves on. And then there's another one further down. But the first function the thing's going to call, once it's declared all, initialized all those variables and things, is going to be the setup function. This only runs once. The first thing we're going to do is, this is telling us we're going to use the serial port, and this is its baud rate. That will allow us to print out, debug while we're debugging the code, and look at the time and what's going on. Very, very useful. Next one is, this is our DFPlayer, if you remember. So we're now just saying we're connecting that up at a lower speed baud rate. This is the default. And then we're actually printing out to our original serial port just a bunch of stuff that says that we're initializing the player. This is the line that actually initializes and checks whether it gets a response or not. So that's why there's an if statement. So basically, it's reading via this function. If it returns a 0, which is a good value, a bad value, sorry, it will print out unable to begin and tell you a couple of things to check. The connection or the cards or whatever. But if it's good, then it will move out of this function and say, you know, serial player mini is online, and it sets its volume to the maximum. I don't see the point in having less than the volume maximum for this. If you are driving directly speakers, the thing can have a tendency to overheat if the speaker impedance is low, but for the DAC output, use maximum volume. We're then just setting up all of our inputs and outputs, telling the Arduino compiler whether they're outputs or inputs. We're printing out start, we're printing out the start time, and then we're waiting 3 seconds for everything to stabilize. Probably not needed, but the DFPlayers can be a little bit on the finicky side if you then want to trigger them straight away. Now we have another function here called play sound and light. I'll get to in a moment. We're going to skip forward to the main programming loop. So this is the thing that runs over and over and over again, hence the name loop. And let's have a quick look at what it's doing. So the first thing it's doing is it's working out the time by calling the built-in millis function. So this uses the internal timer of the Arduino to work out an accurate number of milliseconds. And what it does is it works out seconds, and then it also works out minutes. And I'm interested mainly in the minutes on this one. I don't care about hours because the thing is never ever going to count up to hours. And what I have here is effectively checking that these seconds hit 60, you turn over onto a new minute, and then you actually reset your original timer. So you're just counting up a minute each time, but in seconds. Next section is the two different knobs that you can move on the outside of the thing. The first one, the sensitivity knob. You're reading an analog level, calling it lower threshold. Then I'm comparing it to the old version -5 or the old version +5. If it falls outside of those ranges, then in this case we're going to use, if we've got our debug command on, we're going to print that out on the serial port, and we're also going to make an older version of it so we can make that comparison each time the loop runs through. Now this is really just for debug stuff. the lower threshold just gets used every single time through the loop, and it also gets used while we're actually calling our play sound function. I'll show you that later. The next one though is reading the other potentiometer, which is our delay. So this is the delay between the storms. It's trying to see whether you're fiddling with the knob and want the thing slower or faster between the storms. It reads it in, it prints it out if the debug is on, and then it uses a map function. So a map allows you to map one number quantity to a different range. So the delay pin read could be anywhere between 0 and 1023 in value for the potentiometer, and I'm mapping that with this function between 1 minute and 60 minutes. So when you have the thing on its potentiometer on its minimum setting, you're getting a minute between thunders. When it's on the other end, it should be 60. In real life, you're going to get some variation on that, but it's going to be close enough. And again, similarly to this filtering we did here, we're now going to do a little bit of checking to avoid fluctuations on the knob, because it's not going to give you exact reading every time. So we're looking for a plus or minus 1 minute. If you get somewhere between there, then we're going to print it to say that there's a delay changed. Now, how does it play the show? Well, here we go. The output from this function, which is between 1 and 60, are minutes to trigger. We are counting up the minutes up here. So we have a little quality check here. If this matches the minutes to trigger, then we're going to print the time and we're going to call the function play sound and light. Now, if we move up, so this loop is going to go over and over and over and over again until it hits this function. Minutes equals minutes to trigger, then it plays this function. It's going to go up here to the function. It loads and plays the sound file pointer, which in my application at the moment is only ever sound track 1, because it's my long thunder track. It's going to have a very short 100 millisecond delay, and it's going to print on the console starting sound. Now we've got a bunch of different if then else's and reads, all within a do while loop. So the do while loop is going to be checking that busy pin from the DFPlayer. So basically, while it's playing the Thunder soundtrack, which in my case is about a minute long, it's going to do this over and over and over again. As soon as you are not busy, i.e. it's finished playing, it will drop out, it will say end sound, and it will exit the function. So while it's in the function, in the do while loop, what's it doing? Well, it's reading the level from the DFPlayer Mini, assigning it to this value. If we've got debug on, we can print it out. It's going to be a lot of printing because it reads pretty fast. And then we're comparing it against those thresholds for the sensitivity. If it's less than the low threshold, we have all the MOSFETs turned off. We're in darkness, right? If the thing is between this threshold and this one, we're turning one of these outputs on. If it's between this one and the next one, then we're turning 2 of them on. And finally, if it's greater than the upper threshold, we turn all of the LEDs on. So each one of these goes effectively in turn from all off to the least bright, next bright, full bright. And on full bright, all of them are turned on. What we then do is, if we were to do this normally with just checking that threshold before we hit the function, we would only be able to adjust the sensitivity when it wasn't playing. Well, that's not ideal, because that's when you want to adjust the function. When it's playing, you want to be able to just tweak that knob, get the effect just right. So we actually reread our sensitivity pin in this function, and we update the value live in there. And what that allows us to do, as I say, is you can adjust the thing on the fly. So you're playing the thing, your thunder track's going, you can adjust the knob, and it's then adjusted. So that's a very brief run through of the code. It's pretty simple. Just follow it through slowly. There's nothing crazy and wild about how this is set up. You know, have a look at the schematic, see how it maps to these pins. You'll see how they all line up and how the system is put together.
Okay, so here it is functioning. See the sensitivity I can adjust, make it or less sensitive. Here it's only going to come on when it's really, really loud. Here it's coming on more. Got my 3 DC lights, 1, 2, and the strip light. And then I've got my AC light as well. I'll sync to the sound. This is a very quick demo of the thunder and lightning setup outside. It's broad daylight. I just wanted to show the setup before it gets dark. So here's a little controller. It's got a couple of white wires coming out to, this one's coming to a lamp in housing, and the other side exactly the same. There's a pair of speakers which are connected to this little mini amplifier here. A couple of power supplies for them, and I've also put some 12-volt lights on. There's a little tiny spotlight here, it's not very powerful. Another little homemade spotlight here, and then also linked it to this long strip here I've kind of looped around top of my garage. So that will give you the impression of lightning striking, I hope, when it's dark. So if we view it from a long distance, really bright.